Hi children, students, parents and teachers. A grand welcome to Class 8 Mathematics. This is yours Kona Kiran Reddy. In the series of NCERT Exemplar problems, we are doing the problems from rational numbers. In my previous two videos, I worked out problems 1 to 47. Now in this video, let us start from problem number 48. Before starting, my sincere request to you is, if you like my videos or if you like my explanations, please share, like, comment on my video. Don't forget to subscribe my channel. This is Kona Kiran Reddy, and quickly let us go to the problems. Here you can see in each of the following state whether the statements are true or false. 48th problem. If x by y is a rational number, then y is always a whole number. That is the problem we have. What is a rational number? A number which can be written in the form of p by q, where p and q are integers. So here in this case also, x by y is a rational number means x and y must be integers. Okay, not whole numbers. Right. So x and y must be integers, not the whole number. But here we are given y is always a whole number. No, it is not correct. Y must be an integer. And moreover, that is not equal to 0. Why? Because y is in the denominator. So this is false. Now go to 49. If p by q is a rational number, then p cannot be equal to 0. Is it correct? No. Actually, denominator q is not equal to 0. There is no condition for p. The only condition is p and q must be integers. That means p must be an integer. Q is not equal to 0. So p cannot be equal to 0 means no. P can be equal to 0. So this is false statement. Now 50. If r by s is a rational number, then s cannot be equal to 0. Yes, where is s? Yes, you see here, s is in the denominator. So denominator can't be equal to 0. So that is why s can't be equal to 0. So this is a true statement. Now let us see 51st problem. 5 by 6 lies between 2 by 3 and 1. To check whether 5 by 6 lies between 2 by 3 and 1, so that means here we need to compare 2 by 3, 1 and 5 by 6. How can we compare fractions or rational numbers? By equalizing the denominators. That means by converting them into like fractions. So here in the denominator of 5 by 6 we have 6 we have in the denominator. So 2 by 3, let us convert this into the fraction which has 6 in the denominator. How? 2 by 3 times multiply numerator and denominator by 2. So it will become 2 times 2 is 4 divided by 3 times 2 is 6. Now let us take 1. 1 equal to 1 multiplied by 6 by 6. This is equal to 1 into 6 is 6 by 6. Now these numbers are 2 by 3 equal to 4 by 6 and 1 is equal to 6 by 6. In between 4 by 6 and 6 by 6, 5 by 6 is there. So 5 by 6 lies between 2 by 3 and 1. This is true. Right. Let's go to the next problem. Problem number 52. 5 by 10 lies between 1 by 2 and 1. Here we need to compare rational numbers. How can we compare rational numbers? By equalizing the denominators. That means by converting them into like fractions. So here 5 by 10 means in the denominator we have 10. So let us convert 1 by 2 into the fraction which has 10 in the denominator. How? 1 by 2 times multiply both numerator and denominator by 5. So 5 by 5. This is equal to 1 times 5 is 5 divided by 2 times 5 is 10. You need not to convert the second one, that is 1. Why? Because first one we got 5 by 10. First rational number we got 5 by 10. Here we are given 5 by 10 also. That means 5 by 10 is equal to 5 by 10. So how can it be in between 1 by 2 and 1? So this is false statement. Right. Once again let me explain this one. 5 by 10 we need to check whether this is in between 5 by 10 and 1. In between these two, does we have 5 by 10? No. Why? Because 5 by 10 equal to 5 by 10. So 5 by 10 will not be between these two. So this is a false statement. Now let's go to 53rd problem. Negative 7 by 2 lies between negative 3 and negative 4. Here also let us convert negative 3 and negative 4 such that their denominators are 2. So we can convert negative 3 equal to negative 3 times 2 by 2, which is equal to negative 6 by 2. And negative 4 we have, this is equal to negative 4 times 2 by 2, which is equal to negative 8 by 2. Now you see negative 7 by 2 is in between these two. Here we have negative 6 and negative 8. So in between we have negative 7. So negative 7 by 2 lies between negative 3 and negative 4. So this is true. Instead of doing all these things, we can do one thing. 7 by 2 means we know that 7 by 2 equal to 3.5. So negative 7 by 2 means negative 3.5. Surely this is in between negative 3 and negative 4. So that is a true statement. Now let us go to next problem. That is 54th problem. 9 by 6 lies between 1 and 2. Now let us convert 1 and 2 as the fractions which have 6 in their denominators. So 1 equal to, we can write this one as 1 times 6 by 6, which is equal to 6 by 6. 2 equal to 2 times 6 by 6. This is equal to 12 by 6. Now in between this 6 and 12 we have 7, 8, 9, 10. Do we have 9 between 6 and 12? Yes, surely. So 9 by 6 is in between 6 by 6 and 12 by 6. So that means 9 by 6 is in between 1 and 2, surely. So that is a true statement. 54th is true statement. Right. Let's go to the next problem. Problem number 55. If A is not equal to 0, the multiplicative inverse of A by B is B by A. Multiplicative inverse is nothing but reciprocal. How can we get the reciprocal? Just simply switch the numerator and denominator. That means if you take A by B, then the multiplicative inverse or reciprocal will be B by A. That's it. So this is correct. So this is true statement. Next, let's go to next problem. 56th. The multiplicative inverse of negative 3 by 5 is 5 by 3. What is the multiplicative inverse of negative 3 by 5? That is 5 by negative 3, or we can say this one as negative 5 by 3. This is the multiplicative inverse or reciprocal. But given that the multiplicative inverse of negative 3 by 5 is 5 by 3, that means they ignored the minus symbol. So that means this is a false statement. Now you see 57th problem. The additive inverse of 1 by 2 is negative 2. That is what we have. What is the additive inverse of 1 by 2? That is negative 1 by 2. Additive inverse of 1 by 2 is negative 1 by 2, not negative 2. So this is a false statement. Next one. If x by y is the additive inverse of c by d, then x by y plus c by d equal to 0. Yes, that is correct. Why? Because suppose if we take a and the additive inverse of a is negative a, if we add these two, what will we get? This is equal to 0 we will get. So here also x by y is the additive inverse of c by d. That means if we add these two, surely we will get 0. So x by y plus c by d equal to 0. This is the true statement. Next, 59th problem. For every rational number x, x plus 1 equal to x. Don't get confused here. Given that for a very rational number x, x plus 1 equal to x. This is true or false? That is what we need to check. X plus 1 equal to x. Is it correct? Suppose if we take x4, 4 plus 1. This is equal to 4 plus 1 is 5. This is not equal to x. X means 4. Is it correct? So 4 plus 1 equal to 5 but not equal to 4. So that is not correct. So x plus 1 is not equal to x. So this is a false statement. Let us move on to problem number 60. If x by y is the additive inverse of c by d, then x by y minus c by d equal to 0. No, this is not correct actually. Suppose if we take a, the additive inverse of a is negative a. So if we take a minus of minus a, that is equal to minus into minus plus. So a plus a, that is equal to 2a we will get, but not equal to 0. So x by y minus c by d is equal to 0 means that is a false statement. Let us go to problem number 61. The reciprocal of a non-zero rational number q by p is the rational number q by p again. What is the reciprocal of q by p. For q by p, the reciprocal is p by q, not the same number, right? So this is not correct. This is a false statement. You observe here, here we are given q by p. Reciprocal is also given that as q by p. So that is not correct. Okay. Now let's go to 62. Problem number 62. If x plus y equal to 0, then negative y is known as negative of x, where x and y are rational numbers. Be sure here, don't get confused. If a plus b equal to 0, then b is negative of a, not minus b. Don't get confused. Here in this case, b is negative. B is negative of a. Here also in this case, if x plus y equal to 0, then y is negative of x, not negative y. So this is a false statement. Don't get confused. If x plus y equal to 0 means x is negative of y and y is negative of x. Right, understand? So be sure y is negative of x. Okay, not negative y. Now let us go to next problem, that is 63. The negative of any rational number is the number itself. Yes, this is correct. Suppose if you take any number, suppose let me take 4. Negative of this number is negative 4. Negative of the negative, that means if you take again negative, this becomes minus times minus is plus. So this is equal to 4. So negative of any rational number is the number itself. That is correct. This is true statement. Next, 64th problem. The negative of 0 does not exist. Actually, 0 is neither positive nor negative. So it has no negative. Right, so this is a true statement. Be sure 0 is neither positive nor negative. So we can't say the sign of 0. Right, so it has no negative. Right, so that is why this is a true statement. Then 65th problem. The negative of 1 is 1 itself. Actually, the negative of 1 is negative 1, not 1. So this is a false statement. Then 66th problem. For all rational numbers x and y, x minus y equal to y minus x. Is it true? No. You can take just simply one example. You take x equal to 1 and y equal to 2. So then 1 minus 2, is it equal to 2 minus 1? Is it correct? 1 minus 2 equal to 2 minus 1. 1 minus 2 is negative 1, whereas 2 minus 1 is 1. So these two are equal. Is it? No, this is not correct. So this is a false statement. Now let's go to 67th problem. For all rational numbers x and y, x into y equal to y into x. Yes, this is correct. If you multiply any two rational numbers, order does not matter. You can multiply in any order. So suppose if you take 3 times 4, 3 times 4 is equal to 4 times 3. So this is a true statement. Let us go to the next problem. 68th problem. For every rational number x, x times 0 equal to x. X times 0 equal to, if you multiply any rational number with 0, you will get 0 actually, not x. So this is false statement. That means x times 0 equal to 0, not x. X times 0 equal to x, when will be happen? When x equal to 0 only. When x equal to 0, then it is true. But for every rational number, that is what we are given. So it is a false statement. 69th problem. For every rational numbers x, y and z, x plus y into z equal to x plus y times x plus z. Actually, it looks like distributive property, but be sure this is not distributive property. What is distributive property? If we take x times y plus z, this is equal to x times y plus x times z. This is what distributive property. So that means x times we should have in the left side. But here you see x plus we have. Okay, so this is not distributive property. Now x plus y times z means we can write this one as x plus y z. That's it. So this is not equal to x plus y times x plus z. So this is a false statement. Next 70, problem number 70. For all rational numbers a, b and c, a times b plus c equal to a times b plus a times c actually. But given that here you see that is b times c is given. Don't get confused. A times B plus C, that is equal to A times B plus A times C, not B times C. So don't get confused. So this is false statement. 70, problem number 70 is false. Next, let us go to 71. Problem number 71. 1 is the only number which is its own reciprocal. Here you observe carefully. 1 is its own reciprocal. That is correct. But 1 is the only number. Means there is no other number which is its own reciprocal. That is the meaning of this one. Actually, there is one more number. That is -1. -1 is also its own reciprocal. So this is a false statement. Why? Because given that 1 is the only number which is its own reciprocal, but we have one more number, that is -1. -1 is also its own reciprocal. So this is the false statement. Next, 72. -1 is not the reciprocal of any number. No, -1 is the reciprocal of itself. So this is the false statement. -1 is not the reciprocal, that is given, but it is the reciprocal of -1 again. So it is not correct. So it is a false statement. Next, 73. For any rational number x, x plus -1 equal to -x. Actually, x times -1 equal to -x. But x plus -1 means that is actually x minus 1. So this is not correct. So it is a false statement. Next, 74th problem. For rational numbers x and y, if x is less than y, then x minus y is a positive rational number. For this, let us take one example. For rational numbers x and y, if x is less than y, so x is smaller than y. So let us take x is 1, y is, let us take like 3. So 1 is less than 3, that is correct. Then x minus y is a positive rational number. Let us check. X minus y means 1 minus 3. 1 minus 3 is how much? -2. Is this a positive rational number? No, it is not a positive rational number. It is a negative rational number. So this is a false statement. So false. Next, 75th problem. If x and y are negative rational numbers, then so is x plus y. That means if x and y are negative rational numbers, then x plus y is also a negative rational number. That is what the meaning of this one. If we take x and y as two rational numbers, two negative rational numbers, surely if we add two negative rational numbers, we will get again a negative rational number. So this is a true statement. If we take -2, -3, if we add these two, you will get -5, like that. 76th problem. Between any two rational numbers, there are exactly 10 rational numbers. This is false statement. Why? Because there will be infinite number of rational numbers between any two rational numbers. Next, 77th. Rational numbers are closed under addition and multiplication, but not under subtraction. Under addition, whether rational numbers are closed. Let us check. If we take any two rational numbers, suppose if we take any two rational numbers, then if we add them, whether we will get another rational number or not. Surely, if we add two rational numbers, surely you will get again rational number. So this is true. This is correct. Then multiplication. If you multiply two rational numbers, you will get again a rational number. So this is also correct. Let us go to next, subtraction. Here we are given that it is not under subtraction. That means if you subtract two rational numbers, that means if you subtract one rational number from another rational number, that is the resultant number is not a rational number. That is what we are given. Let us check. Suppose you take 2 and 4. 2 minus 4, this is equal to -2. Is it a rational number or not? Surely. In the same way, if you take two rational numbers and if you subtract one rational number from another rational number, surely the resultant number is also a rational number. So, rational numbers are closed under the operation subtraction also. But here we are given that not under subtraction. So, this is a false statement. 78th problem. Subtraction of rational numbers is commutative. What is commutative means? A minus B. Here we are given subtraction. That is why I am taking A minus B. A minus B equal to B minus A. That is the meaning of this one. This is commutative property under subtraction. Is this correct? Let's take one example. Let us take A equal to 2 and B equal to 1. So 2 minus 1 equal to 1 minus 2. Is it correct? We need to check. So 2 minus 1 means 1. 1 minus 2 is negative 1. These two are equal? No. So this is not correct. So this is a false statement. So 78th one is false statement. Let us go to next problem. 79th one. Negative 3 by 4 is smaller than negative 2. So to compare two rational numbers, we need to equalize the denominators. So here 3 by 4, negative 3 by 4 means 4 is in the denominator. So convert negative 2 as the fraction which has 4 in the denominator. We do that by multiplying both numerator and denominator by 4. So this is equal to negative 8 by 4. Given number is negative 3 by 4. Now you compare these two. Which one is smaller and which one is greater? Actually negative 8 by 4 is smaller and negative 3 by 4 is larger. Negative 3 by 4 is greater. So negative 3 by 4 is smaller than negative 2. This is not correct. Actually negative 3 by 4 is greater than negative 2. So this is a false statement. Now 80. 0 is a rational number. Surely 0 is a rational number. So this is true statement. 81. All positive rational numbers lie between 0 and 1000. Is it correct? No, it is not correct. There are so many rational numbers which are not in between 0 and 1000. Suppose if you take 1002, this is a rational number and this is not in between these two. So this is a false statement. 82. The population of India in 2004-2005 is a rational number. Surely there is a rational number. Population is always a whole number. So all whole numbers are rational numbers. So this is true statement. Population is also a rational number. So true. Next 83. There are countless rational numbers between 5 by 6 and 80 and 8 by 9. If you take any two rational numbers, there will be infinite number of rational numbers between any two rational numbers. So this is true statement. 84. The reciprocal of x power negative 1 is 1 by x. Actually, x power negative 1 is equal to 1 by x. Given that the reciprocal of x power negative 1 is 1 by x. So this is false statement. Don't get confused. X power negative 1 equal to 1 by x, that is correct. But reciprocal of x power negative 1, that is given. So reciprocal of x power negative 1 means 1 by x power negative 1. That is equal to, actually that will be x. That is equal to x. So this is a false statement. Now let us go to the next problem, 85th problem. The rational number 57 by 23 lies to the left of 0 on the number line. If you take the number line, left of 0, there will be negative numbers actually. So left to the 0, negative numbers will be there. But 57 by 23 is positive number. So it will be right side to 0 on the number line. So this is the false statement. Next 86. The rational number 7 by negative 4. 7 by negative 4 is nothing but that is equal to negative 7 by 4. That means this is a negative number. Okay. Lies to the right of the 0 on number line. Is it true? No. False. Why? Because right of the 0 we have positive numbers, not negative numbers. Negative 7 by 4 or 7 by negative 4 will be at left side actually to 0. So this is a false statement. Next 87. The rational number negative 8 by negative 3 lies neither to right nor to left of 0 on the number line. What does it mean? Neither nor. Neither nor means both are not correct. That is the meaning of that one. Neither right nor left. That means negative 8 by negative 3 is not at the right and not at the left. That is the meaning of this one. Now negative 8 by negative 3 means minus minus gets cancelled. This is equal to 8 by 3. So this is a positive number. This is greater than 0. Positive number. Positive numbers, all positive numbers lie on the right side of 0 on the number line. So 8 by 3, that means negative 8 by negative 3 is also at the right side to the 0 on the number line. So this is false statement. Given that there is neither right nor left. So that is not correct. It will be at right actually. Let us move on to the next problem. The rational numbers 1 by 2 and negative 1 are on the opposite sides of 0 on the number line. Yes, 1 by 2 is positive, whereas negative 1 is negative. So surely these two will be on the opposite sides of 0, but not at equal distances, be sure. So this is a true statement. Next, 89th one. Every fraction is a rational number. Every fraction means fraction is in the form of like 5 by 7 or something like so. It is in the form of p by q. So every fraction is a rational number. Yeah, that's correct. So this is a true statement. Next, 90th problem. Every integer is a rational number. Surely this is also true. I think need not to explain much on that one. Next, 91st. The rational numbers can be represented on the number line. Yes, surely we can represent rational numbers on number line. So this is a true statement. 92. The negative of a negative rational number is a positive rational number. Suppose we have negative 5. This is a negative rational number. For this again if you take negative, so that means negative of a negative rational number. This is equal to minus into minus plus 5. So surely negative of a negative rational number is a positive rational number. So this is a true statement. Next problem. If x and y are two rational numbers such that x is greater than y, then x minus y is always a positive rational number. X is greater than y. That means x minus y. Subtract both sides by y. So x minus y is greater than y minus y. So x minus y is greater than y minus y means 0. So this is correct. You can take one example for this also. If you take x is 5, y is 2, suppose x minus y means 5 minus 2. So that is equal to 3. Like that. If x is greater than y, then x minus y is always greater than 0. That means it is a positive rational number. So this is a true statement. Next, 94. 0 is the smallest rational number. Then what about negative numbers? Negative numbers are smaller than this 0. So this is not correct. So this is a false statement. There are negative numbers which are smaller than 0. So this is a false statement. Every whole number is an integer. That is correct. This is a true statement. Every whole number is integer as well as rational number also. Then 96. Every whole number is a rational number. Yes, that is correct. This is also true statement. 97. 0 is a whole number, but it is not a rational number. No, all the whole numbers are rational numbers. So 0 is also a rational number. So this is a false statement. Next, 98th problem. The rational numbers 1 by 2 and negative 5 by 2 are on the opposite sides of 0 on the number line. Yes, correct. 1 by 2 is a positive rational number, whereas negative 5 by 2 is negative rational number. Negative 5 by 2 will be left side to 0, whereas positive 1 by 2 or 1 by 2 is the right side to 0. So these two will be on the opposite sides of 0, but not in equal distances, be sure. So this is a true statement. Next, 99. Rational numbers can be added or multiplied in any order. Yes, that is correct. Commutative property holds in rational numbers in the case of addition and multiplication. We can add in any order. So if you take 2 plus 3 or 3 plus 2, both are same. Whenever you are adding, if you change the order, it doesn't matter. You will get the same value. In the case of multiplication also, 2 times 3 is 3 times 2. So that is correct. So this is a true statement. 3 times 2 equal to 6 and 2 times 3 is also equal to 6. So those are equal. So it doesn't matter in which order you are adding or in which order you are multiplying two rational numbers. So it is true statement. Next problem, 100. Solve the following. Select the rational numbers from the list which are also the integers. So first let us start from left side. 8 by 4, this is equal to 2. So this is an integer. Now 9 by 3, this is equal to 3. So this is an integer. 6 by 3, which is equal to 2. That is also an integer. 4 by 2 equal to 2. 3 by 1 equal to 3. So these are also integers. 1 by 1 is 1. Next 0 by 1 means 0. Negative 1 by 1, that is negative 1. And negative 2 by 1, that is negative 2. And then negative 4 by 2, that is negative 2. Then negative 6 by 2, that is negative 3. So all these are rational numbers. All the circled numbers are rational numbers as well as integers. But the remaining numbers, those are just rational numbers but not integers. Okay, right. So with this, we completed 100 problems. Here, let us close this. In my next video, let us continue from 101. Hope you enjoyed the class. If you liked my explanation, share, comment, and before that, please don't forget to subscribe my channel. Thank you one and all. Yours, Kona Kiran Reddy.